Unit 5, pages 161 to 163, more on particle motion, finding net and total distance. The graph below represents the velocity, v of t, which is measured in meters per second, of a particle moving along the x-axis. So this graph is a graph of v of. At what values of t does the particle have no acceleration on the interval 0 to 10? Justify your answer. So we're looking for no acceleration, which means we're looking for when a of t is undefined. Okay, and since a of t is equal to the derivative of v of t, we're looking for when the derivative is undefined on this graph, which occurs at cusps. So therefore, since this is an open interval, we're not looking at the endpoint. Therefore, the particle has no acceleration at t equals 1, 3, 6, and 8, because v of t has cusps. Next, we want to express the acceleration a of t as piecewise defined function on the interval 0 to 10. So remembering that a of t is the derivative of v of t, and that the derivative is accumulation of slopes on an interval, right? So we're looking for slopes of a tangent line on the interval. So that means that we're looking at the different slopes that this graph has, right? So from 0 to 1, we have one type of slope, which is 3. From 1 to 3, we have another type of slope, which is -3. From 3 to 6, we have another type of slope, which is 0. From 6 to 8, we have another type of slope, which is 3. And from 8 to 10, we have another type of slope, which is -3 halves. Right? And I can just figure that out by just doing rise over run on all those intervals. So what that tells me is that a of t, since it's an accumulation of slopes, equal to 3 when t is between 0 and 1, -3 when t is between 1 and 3, 0 when t is between 3 and 6, 3 when t is between 6 and 8, and then last but not least, -3 halves when t is between 8 and 10. So the piecewise defined function for acceleration will be as so. So next we want to determine for what values of t is the particle moving to the right, to the left. So remembering that particles moving to the right when v of t is greater than 0, and to the left when v of t is less than 0, answer this question on your own. Also, find the average acceleration of a particle on the interval 1 to 8. So remembering that average acceleration is v of a minus v of b all over a minus b. And a is my 1, and b is 8. Do this problem also on your own. Now we're going to introduce these two concepts of distance. First distance concept we're going to introduce is net distance, which is the distance between the point of origin and the final position. Right, so that basically means where you started and where you ended. Didn't matter how far you traveled back and forth in between, but where you started and where you ended. Now, total distance is the sum of all distances moved in any direction. So this basically takes into account how far you went to the right, how far you went to the left, how far you went to the right, how far you went to the left before you got to your final destination. Okay, so think of total distance as your step count and net distance as just your overall from point A to point B, how far did you travel? If a particle is moving the same direction the entire amount of time, what can be said about the net distance and the total distance? So if the particle never changes directions and is moving the same direction the whole time, then the net distance will be equal to the total distance. Okay? So to find the net distance of a particle, remembering that distance is always positive, right? So it doesn't matter if it's net distance or total distance, distance is always positive, right? So to find the net distance of that a particle travels on an interval, we first look at the interval. So on an interval, A to B, the net distance is the position at A minus the position at B. And since distance is always positive, we need to take the absolute value of that. Okay? So total distance right? So on an interval A to B, if the direction of motion changes, at some point of time C, on the open interval A to B, the total distance is the position of A minus that position when we change directions, the absolute value of that, plus the position where we change directions minus our final position. Take the absolute value of that. Right? So if we're going to the left, let's say we started by going to the right, and then we change to go to the left. Right? So then the distance that we travel to the right, we want to add that to the distance that we travel to the left. That'll give us the total distance that we traveled. So position of a particle is given by the function p of t equals 2t cubed minus 6t squared plus 8t, where p of t is measured in centimeters. Find the net and total distance of the particle travels at t equals 1.5 seconds to t equals 4 seconds. So our net distance is equal to the position at our starting point, which is 1.5, minus the position at our ending point, which is 4, which is equal to 58.75 centimeters. Now, to find our total distance. We need to find when, if ever, did we change directions, which means we need to find when v of t, which is the same thing as p prime of t, equals 0 and changes from positive to negative. Right? So p prime of t, which is v of t, is equal to 6t squared minus 12t plus 8. On the interval from 1.5 to 4, p prime of t is always positive, which means the particle doesn't change directions on our interval. So if the particle doesn't change directions on our interval, we go back to the beginning of this page, right? If we're never changing directions, then the net distance is equal to the total distance. So the total distance is equal to 58.75 centimeters. Okay. So now for our last page, position of a particle is given by the function p of t equals e to the 2t minus 8t, where p of t is measured in feet. Find the net and total distance of the particle travels from t equals 0.5 minutes to t equals 1.5 minutes. So our net distance is again the absolute value of p of our initial, which is 0.5, minus p of our final, which is 1.5, which is 9.367 feet. Now our total distance we want to find when p prime of t equals 0 and changes direction. So if we find p prime of t, which is equal to e to the 2t times 2 minus 8, which is just 2e to the 2t minus 8, and we set that equal to 0. So p prime of t equals 0 when t equals 0.693. Since 0.693 is on our interval from 0.5 to 1.5, we have to take it into account. So we're going to make a sign chart. So we know that the beginning of our interval is 0.5. We have a 0 at 0.693, and the end of our interval is 1.5. So what happens in between these are what we're looking for. So between 0.5 and 0.693, we will be negative. And between 0.693 and 1.5, we will be positive. So we do change directions. So 0.693 is my C value. So when finding my total distance, we need the distance from my beginning, so P of 0.5, minus when we changed position, so this is P of 0.69, plus the distance of when we changed positions, so P of 0.693, minus my ending point, so P of 1.5. And that gives us 3.617 feet. Okay, so what the net distance told us was that from the very beginning to the very end, we traveled 9 point, oops, I'm sorry, I wrote the wrong answer. We get 9.894 feet. Ooh, that makes more sense. Okay, so the net distance from point A to point B is 9.367 feet. However, if we take into account that distance that we went to the left and the distance that we went to the right, we actually traveled, well, the particle actually traveled a distance of 9.894 feet. Okay, so what I want you to do now is try to do the next problem on your own. Find the net and total distance of the particle given by the function p of t equals t plus 2 sine t.